Hello, hello. Am I audible? Till last. Okay. So, good morning, everyone. It's a great pleasure for me, and especially thanks to Deepak sir for giving me the chance to speak a lot about the machine learning in front of you. About the machine learning. Okay. So, before we start with this machine learning aspects in engineering application, what we will do first, we will talk about the what actually the machine learning is. In general, when we talk about this machine learning, there are the different aspects. Okay. So we will talk about machine learning, about the what it is, where is the application area of this machine learning, when these machine learning algorithms is going to be used.
बाकी बाबर ना से मैं पढ़ा देता हूँ, आप लगा लो उसको। आप बोलिए।
हेलो 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 हेलो
अस्सी कितना आवाज आ रही हो?
हेलो।
हाँ सर, मुझे आ रही है।
नहीं आ रही है, पीछे
आ रही है सर, आ रही है।
आवाज आ रही है वहाँ है इसकी।
हेलो, no issue. Okay, so we will talk about these five basic keywords about this machine learning. So very good question here about that how many of us we actually hear about this machine learning. Most of us we believe that we have a good sound knowledge about this keyword, what the machine learning is. Next, we will talk about actually how many of us we know about the basics of machine learning. There is a common interpretation between the research community that machine learning is equivalent to our deep learning frameworks. Next, we will talk about in a realistic manner, in a true manner, in a correct manner, how many of us we are using machine learning for our engineering application. So, if we are clear about these three aspects, then we think that we can understand about the basic terminology about the machine learning concept. So, we will start with our one basic definition, which is given by the information. A computer program is said to learn from experiences with a class of tasks T and a performance measure which is known as P. So if its performance as a specific task T is measured by P and it actually improves with E. That means in a simple language it will interpret this definition and we can say that with our experiences on any given task, if we are able to improve the performance of any system, then we can say that the system on the algorithm which we are working is on machine learning domain. So before coming to that exact definition, let's think about the learning process. But actually, why we have added this keyword learning with the machine? So what the learning is? So if you will think about the learning aspect, only the learning, basic terminology, psychological aspect, then we can talk about that learning is something, okay, therefore learning without reflection is a way. If you have learned something and the reflection of that is not visible, then your learning is vague. But reflection you have, but without learning, it is quite dangerous. Okay, so we will talk about the aspect and we will come to the direct application of the learning process, and we will say that it is a cycle type of thing where we can think about some abstract conceptualization. Then we can do after we can do that task, we can feel what actually the experiences we are getting from the aspect after doing the thing, and then watch the reflexive action or the observation. And it is a cyclic process that means the whole learning aspects keep on updating, cycling in a cyclic manner. So as your experiences will grow, your learning aspects will also grow. So if you add these keywords with our machine interpretation that this learning is now added with the machine, then what is happening? We can say that in the machine learning, we have the some learning base we learn. With this learning base, we have the some algorithms, we have the deep neural networks, we have the artificial intelligence type of thing, which is actually doing some data mining from the hidden patterns, identifying that, finding some unknown samples, observations, with the help of the classifications we have the some models which is called neural network based models, autonomous models, and beyond that, the overall aspects is to improve and analyze the performance of the data. So, if we will add all these aspects with our machine, then we can say that we are come with a new definition of the machine learning. And that definition, if you will compare the original definition, which is given by Tom Mitchell, and the now the updated definition of the study that gives the computer the ability to learn without being explicitly programmed. Okay, so Tom Mitchell is also focused on the performance, like as your experiences will grow, your machine interpretation or the algorithm on some specific task will increase the performance. While if you talk about the psychological pillars, the machine aspect, we will combine these two aspects and then we can talk about the machine learning. It is also giving us the same interpretation that we want to increase the ability of our computer algorithms so that for any unseen sample or for any hidden data, the machine can give us the outputs in a correct manner, just like a human do. So this whole machine learning environment, if we talk about this learning process, is divided into multiple aspects like your unsupervised learning, we have the supervised learning, and we have the reinforcement. Beyond this, one more type of learning there is semi-supervised. Okay, which is the like a intersection between the two aspects, supervised and the unsupervised. So these three types of learning aspects, they have given us some sub-domain expertise again like a reinforcement. We can see this in our gameplay where we want our dynamic moves based on the experiences, real-time experiences. While for the supervised case, we are more interested about the labels. So we have some supervised data with us and we want to identify the patterns, we want to identify the some aspects that for any unseen samples are we able to find the correct label for that model or for the data. Because this, we have the unsupervised, which is again subdivided into two aspects, which is called the dimensionality reduction and the clustering segmenting. So we will talk about these algorithm aspects later on. So machine learning, these three types of learning, as we talked about, supervised will where we actually know about the labels. Then we have the unsupervised, which is totally blind, and we are actually discovering the patterns. We are not unaware of the patterns, but we are actually discovering those patterns. While the reinforcement is based on your feedback. Once your feedback is there about the data, then we can move on or we can work on based on the feedback and experience. So there is four aspects of classification, segmentation, reinforcement learning is further further analyzed by using a basic machine learning pipeline structure, where we talk about that we have some labeled data like in the supervised case, we have the labeled data with us. These labeled data will go to the our machine learning algorithms, and the machine learning algorithms will help gain the knowledge, gain the information, and it can generate our learn model. Later on, once the unidentified sample will come, this sample will interact with our learned model without being explicitly programmed anything, and then it can directly give us the prediction about that data. So, if we will talk about the very general aspects of a learning process or the machine learning process, then we have some supervised data with us. Using this supervised data, we are going towards the learning aspect, and as our learning will go on, our model will keep on increasing the knowledge. So it's just think about the basic. I will give you a basic example of this learning. Suppose think about one school-based child of class nursery. So that student, when that student will go in a nursery class, teacher will talk about like a character A for apple. Okay. And the students they keep on repeating the things A for apple for some continuous amount of time, like a whole day. And the students keep on learning this A is like this, is seems like this, and A means apple. Okay. So what will happen? This A student keep on learning about this A. But what about say the faculty or the teacher has given an example in a form of capital A. That capital A means A for apple. But what about in case some external agent will give this small a and ask the student that oh, now what is this? Small. Can student remember that part that this small is also a? I think it is not so because the student that certain class student has taken care of only the capital A to understand that this capital A means the A, while small a is not itself to it. So what we are doing, we want our model to learn in that manner, which can give us the broader knowledge. That means it can cover as many aspects and many variations to get learned about the model. So the overall ML workflow will give you the raw data, which is being initially pre-processed. Once the model is pre-processed, we will transform it into the structure form. This structure form is going to be used by the algorithm, and this is a cyclic process. Keep on learning each and everything, all the patterns, whatever is there in a data set, and this cycling process can help us to gain the understanding of the variation about the specific class that this sample meets this label. So this is quite important in a machine learning aspect that your data must have a lot of variables so that the model can learn and will not fall in the two basic problems of overfitting and underfitting. So once your model is being trained or the learned completely, then your sample data or the test data will again go to the pre-process. It is becoming in a structure mode, and your structured test data is now enriched with your final learned model and can give you the prediction of your test data. So if we talk about our next term of computer science is the computer vision. Like what we are visualizing the thing and we are able to interpret, can our computer system can also do the same task? So what is the vision of the computer about this specific problem? So we took one example. Suppose we have taken our medical image acquisition from the any sensor. So this image is initially being pre-processed. We can make the some enhancement, we can learn some segmentation, we got some output, and finally after that we will do the feature estimation and then go for the classification. So, so hello, hello. So what the problem is? Hello, hello. Audible. Okay. So what the problem is with this system? In case if you will talk about the intermediate circle, computer plus software plus the learning aspect. So what will happen in case we are unaware about this circle, then our model is not going to be trained in a completely manner. Okay, this. Hello. So this intermediate part, the circle, is actually the heart of our computer vision system. Computer can only visualize. Computer can only visualize those things on which the computer has the knowledge. In case in a database or in a knowledge base of a computer, that pattern or that information is not available, then what's the problem is machine is going to give you the false. Machine is going to give you the false aspects. Okay, so think about it. There is a child who has learned about ABCD, A to Z, all the characters of English alphabet, and all the variations like a capital A, small a, all the variations he has learned. He has learned each and every form of the alphabets, like a straight line, the slant lines, everything the student has learned. But the problem is, while giving the examination or the test, someone has asked about the one Chinese character. And if we will give you one Chinese character, and no one will tell you what that character means. And it's a simple question, identify the character. Then what will happen? Based on our learning, because we have no experiences about these Chinese characters, but we need to give one answer about that character, so we can interpret anything from our knowledge that this character might be this one. Okay, so this problem exists in case we do not have a strong knowledge base with us. So this knowledge base in a computer vision is the heart of any machine learning systems. So what is next? This knowledge base. Even in an image processing or in a processing level, we have three types of processings, like a low level, intermediate, and the high level processing. These processings can help us to interpret the samples, but only when all these phases can communicate with our knowledge base. So the target of this machine learning aspect is to create this knowledge base, not this whole system. Okay, when we talked about the professionals, we talked about some researchers, what they think about machine learning is this whole system. Like we are acquisition, pre-processing, segmentation, we have the representation, recognition. This all phases are our machine learning. But this is not so. Our machine learning, these all phases are the components of AI-based modeling or the cognitive intelligence. Okay, this is the difference. Cognitive intelligence is a collection of all these phases plus the machine learning. While the machine learning itself is the knowledge base, which we are going to create with our experiences, with our data set, and we can create the knowledge and we will store this knowledge in a form of model. So this will create a knowledge base to us. So these three levels of processing. Low level, it's a standard procedure that is applied to improve the image quality. Again, the visualization. Okay, it's a visualization, visual perspective. We have the process which is required and have no intelligent capabilities. While this intermediate processing, we have the exact and characterized component of the image, and some intelligent capabilities are introduced, like the representations, intermediate representations, segmentations. We can do this with the help of our knowledge base. High level, which is actually required the high intelligent capabilities. That means your data, which is actually transformed into the information. Information is again transformed into the knowledge, and then knowledge is converted into the intelligence. Okay, so the high level processing is actually required the intelligence, not the knowledge. Knowledge is required at the intermediate level. So now we will talk about the last 35 years of this machine learning. So we started in 1980s when we have the era of pattern recognition using only two-dimensional images. We worked on this era for the 4 years. The second one is of the knowledge-based approaches, where the data is converted into information and later the information is converted into knowledge, and this knowledge can help us to give us the intermediate results or the intermediate processing stage. Later, in a 92 to 98, we have moved towards the more informative, like a three-dimensional image, towards integrated analysis. We are moving towards the hybridization of type of things. Later, machine learning with a shallow reasoning. At this place, in a 99 onwards, you will see there is a large evolution of neural network type of aspects in a machine learning. Before that, we actually relied on SVMs, KNN, different type of algorithms. But while in the 99 onwards, the boom of neural networks in a machine learning came in a market. 2010 onwards, we will move towards the intelligence machine learning with complex reasonings. Now what is happening? We have the information. This information with some external agents is going to convert it into the intelligence. Okay. So intelligence, we are able to generate a more intelligent machines like the robotics. So AI came in a market with some more generalized robotics type of thing, which can create the intelligence in a market. And 16 onwards, the era of deep learning, where you are now leaving behind the machine learning aspects phases, and we are actually moving towards the deep learning, where we are getting some improvements in accuracy and the architecture point of view, and the headache of phases to implement the machine learning phases is somewhat resolved. So these paradigm, if we will talk about, that means from these last years, from 80 to 2016, we have converted our knowledge to data-driven approach. Initially, we are on the knowledge-based approach, where we have to capture the model, we have to prepare, we have to train, we have to apply, and keep on repeating the things so that we can get the much experience. But now, this knowledge is transformed into intelligence, and we move towards the new aspects of learning, which is called the data-driven. Data-driven means in a computer science, we have a different branches like the artificial intelligence. We have some curated knowledge. We have the reverse engineering type of thing. We have the machine learning. We have data mining. Day by day, these data are increasing, coming in a market. Keep on adding a multi-model data sources. All the data sources are keep on increasing day by day, and this can give rise to our big data analytics type of thing. And this whole framework is called data engineering or data science, where we have a multi-model type of data. We have a big data framework. Using the big data, we can use the machine learning, artificial intelligence aspects, and we can solve these problems which are having nowadays very big data sets. So finally, AI is having a power of machine learning inbuilt. Machine learning is having a deep learning. So if we will talk about these things, there is a big confusion like deep learning and the machine learning are two different aspects. Okay, but it is not so. Machine learning and deep learning, machine learning has some extra capabilities, while deep learning is a type of black box to us. If we will talk about the phases of these machine learnings, these machine learning phases are actually human oriented. You need to apply the phases one by one in a sequential manner, and all these phases can give you some output. Collective output of all these phases can help you to solve some problem. So here you need to implement, here you need to think about it, some general new things, and then only we can solve the problem. While in a deep learning, we are actually having the pre-models, we are actually having the black boxes, we can give the input to that box and we can get the output. But intermediately, believe me, if we will talk about 1,000 people, 990 individuals, they are totally unaware actually how the deep layers are actually working on. We know there is a CNN layer. We know there is a fully connected layer. We have the different architectures of different deep models. We pass the input, we get the output. That's it. Those who have designed these models, they have given the model open source, you can use it and you can take the output. But actual, if you want to design some new neural network or some new deep model, then we must know about the working of these layers, and that we can only do if we will know about the machine learning phases. So after these basics of deep learning, machine learning, AI, cognitive intelligence, how these are interrelating, the era of deep learning, if you will allow me, then I can say that artificial intelligence in nowadays is a reflection of computer science. Everywhere you will find this buzzword artificial intelligence. And this artificial intelligence nowadays is actually the most intelligent creature ever done by the human. And not only most intelligent, but also independent. So this artificial intelligence, which is an intelligent machine, which can predict something on the basis of the learning plus external knowledge, okay, and then it's an independent. Independent means there is a no correlation that only the problem can be solved using one model, but that model cannot be used some other aspects. It's an independent. You can use any model, you can club any models, you can make the hybridization. All models are independent, they are extendable, they are reducible. So based on our learning aspects, we can change the dimensions, we can change the architectures of our pre-trained models. So any doubt by anyone in this point, then please ask. Okay, so as per the faculty or the research scholar point of view, every data is useful to us. We cannot say that we can work only a single type of data. Only I can work only on images. No. Either the data is in a form of images, it is in a form of text, it is in a form of audio, it is in a form of videos. All the data, all the multimodal nature of this data is actually important to us. And we need an algorithm, we need our model that can help us to read all these type of data, and so that the model can be extendable to any problem domain. If we will move towards a single domain problem, then that model is not feasible to the research community. So we need to generate that type of model. We need to apply a design thinking on the data. This data keyword is really important in a machine learning. So we need to design our thinking aspects like emphasize on which data we want to play more emphasis. Second is a define. Now later define this data, what this data is, what type of nature this data is having. Then iterate. You keep on iterate this data so that your model can learn all the aspects, all the patterns of this data set. Then create a prototype. Once your data is trained, all the variations you have used, then you have created a one prototype that is now ready to test in a market. So think about these two aspects. Create the project for some local problems. Why we are always taking care of some global problems using our machine learning models or the AI-based engine. Let's think about some local problem. Traffic jam. Can we have any such machine learning AI-based system that can give us the prior knowledge without searching the Google map that on this path we are having a heavy traffic jam? Can we do this? So in case we are able to find a solution of this problem, so once I will start leaving my home, I get the reminder your daily route is having a heavy traffic jam. You can move towards the alternate path so that you can reach 10 minutes early. So can we have this solution in a market? Second, you will check out the photo about one road accident. It's not an accident, it's a natural disaster. Road actually dumped. Okay. So do we have any such system, underground sensors type of thing, which can help us to identify that, okay, the strength, the road strength here is now below the par level, so that the traffic need to be stopped before some accident happen. So these are the sensor-based applications. In case we have these sensor type of things incorporated in a machine learning domain, then we can create a one intelligent application that can solve some realistic problems of the market. Okay, so this IoT, the keyword IoT, which we talked about, it is not falling in a machine learning. What we talked about? Machine learning with some external agent, external knowledge. Once we incorporate this external knowledge with the machine learning, we can create an intelligent application. And this is what we talked about in our AI-based engines. So what is the? We need to convert the projects to AI-enabled projects. Most of us, what we will do, we will create those projects where we can do a classification task, where we can do the segmentation, where we can do the prediction. We have only 3 class levels, not levels. We have the 3 domains. Either we are working on supervised, we are moving on unsupervised, or we are moving in a reinforcement. And we claim very proudly that I am getting a 90%, 96% accuracy. But actually that accuracy is not solving any problem of the real life. So what we need? We need to convert that project idea into the AI enabled. That means we have to create some external agent. We have to bring some external agent and we incorporate with our project this external agent so that you can get a realistic solution of any problem. So in this whole thing, how we can do this? We have the project life cycle on which we actually worked on. We have the features. These is included in our project. We have the features of some different aspects. Second, different data set. We have the project. we have a third project with some different features. So we have the multiple type of feature, which is actually we gain this from all the phases of our machine learning product lifecycle. Okay, so once we have the phase-wise features, we have taken these features to our product lifecycle, and we are now moving towards the extension of this project. Like phases-wise, if we have the data that in this phase 1, we have these number of features, phase 2 is giving me these number of features, can I incorporate any AI-based agent in the system so that my features will become more realistic, my features will become more informative, my features will give me some realistic domain, and for which I can apply in some generalized solutions, real-time solutions, and can get my data. So some applications, here we go. I am not going into the very deep. I will cover only 1 or 2 applications right now, because as per your curricula of this FDP, most of the algorithms classification and other thing is included in tomorrow's lecture. So I am taking only the overview of some applications like speech recognition. Now think about the complexity of this speech. Even in a Google search, we have a button search by voice. And once we will click on that part, search by voice, we will speak some words, and Google is transformed that speech into the text, but that text is not 100% correct. Based on your modulation, your voice, Google can interpret the keywords and it can transform. So even Google has no 100% algorithm, working algorithm that can convert your speech into the text with 100% accuracy. Okay. So what is included in this speech recognition task? Your speech is going to have some patterns. These patterns is going to be analyzed. And what we will do, we have the accents. What type of accent you will use? We have the language recognition models. What type of models we are going to recognize the keyword. Then we have the emotions. What are you sad? Are you happy? In what emotion you are talking about that keyword or the speech. We have the gender recognition using the speech, whether the voice is of male or female. Then we have the speech recognition and speaker recognition. Based on your voice samples, we have the 2 class levels, like a speaker recognition, who is actually speaking. And the one is the speech recognition, what type of speech it is. It is a neutral voice, it is sad, the person happy. So based on your voice modulations, patterns, you can transform with the help of machine learning that speaker is having what type of mood, which is actually called also as a affective computing. Then we have the speech to text or a text to speech, as we talked about the voice words or the Google. So these Google or the voice-based Alexa, these are workable on your speech to text and text to speech. Like if you want to listen some theory written Wikipedia, and you want that Wikipedia will give you all the details in an audio manner so that you can quickly interpret. Yes, now we can do that. We can change this. We can change speech to text. We can change text to speech, but how much accuracy we can do this is the task. Because we are only claiming about the accuracy level till date. We are getting 100% accuracy, 90% accuracy. Okay, done. We are having the accuracy. But what about if we will change the modulation or modulation change? Think about a more complex language, Hindi. Can you convert Hindi into English efficiently? Is there any model which can convert Hindi into English? We have the Google Talk, Google Translator, transliterations. Okay. Think about it, the complexity. In a Hindi, we have some keywords aap, tu, tum. Okay. These three keywords, and in English, we have only one keyword, you. Okay. Now think about it, the association. Think about it, the feeling, which is actually associated with the speech. Okay. That is not available in our transformed English language. Okay. That aspect is totally missing. Okay. If we will talk about some other words in Hindi, which is actually not available in the dictionary, we will use some keyword like some persons use jhakas, bindas, lallan top. Can you transform these keywords in English? They can simply transliterate English. They can transform it into a Hindi to English. We do not have such words. So how? What type of complexity we have? So this is only the Hindi to English, and talk about the more general specific language specifications like Hindi to Kannada, Hindi to Tamil. Can we change? Can we change that part? Again, a more complex type of thing. Done. Same way, transforming English to Hindi is again more complex. Like because we will talk about the because. In Hindi we want to write because को मैं लिखना चाहता हूँ क्योंकि, and now क्योंकि में क्या आधा बनेगा, की मात्रा इधर से आएगी, छोटी बड़ी छोटा हो बड़ा हो. These type of complexities, do we have any algorithm which can able to understand कि ये मात्राएं, where these matras will come? So syllable, this accent or syllable खींच कर बोला जा रहा है, नहीं खींच के बोला जा रहा. हम लोगों ने we have talked this thing about in our schooling that if we are taught क्योंकि खींच के
अभी तो
बोला
कर रहा हूँ, इसलिए थोड़ा सा वेट कर रहा हूँ.
Okay, then we have these type of things which is not actually exist till date, which can solve these problems. So we have a lot of scope with the machine learning to improve on. Now we have done this language generation models. So transliteration, same way, the speech. Now scene interpretation. Talked about the damaged car or damaged house. We have captured these image. We will move towards our vision system where we have done the processing. We have find the image database. We have the pixel recognitions. We have the models, and we have made the assessment or what is the repair cost evaluation of these two aspects. Okay, so we have these 5 steps. Image capturing, called an image acquisition from the scene. Then we have the pre-processing, database creations, we have the recognitions, we have our models, we have our interpretation. So these aspects up to the computer vision we can solve. Actually, here is the place where we apply our machine learning models up till this place. Beyond this, if we check about, we have the structured data, we have the semi-structured data, we have the totally unstructured data, we have some streaming type of data. So in this phase, the step 3, the image database or the learning on which my model will keep on gaining the experience is having what type of data? It is a real-time streaming time series data. It is totally unstructured raw data. It is fully structured, completely supervised, or it is semi-structured, halfway unsupervised, halfway supervised, like this type of thing. So this artificial intelligence has a broader view of this system. So machine learning is the core knowledge where we can generate the knowledge base, while AI is having a interaction with this machine learning with some external agents, specifically about this data part. So overall, till this part, I have covered some aspects of this computer science. We have the AI. AI is having a part of machine learning, where we discussed about the supervised, unsupervised, and the reinforcement. Later, machine learning is of two types: statistical, where we have the natural language, speech recognition type of thing, or second hand, we have the deep learning frameworks, where we can use the convolutional layers, convolution models, a black box type of things, and we can solve our problems. Beyond this, AI is also having the symbolic representations, which is called the computer vision, robotics, image processing, which actually works only and only on vision type of thing, where we can look, feel. What we are interpreting, can computer also interpret in a same manner. So we have covered till this point up to all these aspects of our machine learning and AI systems. Okay. Now, later we concerns before we start. As I talked in a previous slide, we have a bigger concern on our data. In these 2 days, I will talk about all the phases of machine learning, what actually the concerns are, what is the limitations, what all are the aspects. So think about this data. Once we start our machine learning experimentation or the research or our working with the machine learning, the very first question with us is about the data. And how much data do we actually need to make our model to work in an efficient manner? Second, what if we do not have enough data? Are we not able to work on the machine learning models? What if we do not have enough annotations? Annotations means if we have annotations, then we can work on a supervised manner. We have the predefined classes with us, and using these predefined classes, we can solve a problem. But what about if we do not have these annotations? That means we are working on unsupervised manner. Then how much data we need? What if we do not have enough data? So these are the 3 concerns for which we talked about. So before coming to these concerns, actually, we must know what actually the data is in machine learning community. Okay, so on which parameters we can classify these data. So this type of data in a machine learning, we have a quantitative and the qualitative. 2 aspects of machine learning we have. If we will talk about the qualitative, we have the nominal data and the ordinal data. Like a nominal, we have the genders, name, we have some labels, hair color, we have the other aspects of the data. While ordinal, we have the letters, we have some statuses, we have grades, we have some numeric values which is coming under this discrete and the continuous part. So based on these values, based on these type of data, our machine learning phase to get the features is going to change. Why this data play a crucial role in machine learning? Because if we have a data nature, we have the algorithm with respect to that data. This is not so that one algorithm is applicable to every type of data. Okay, if I will talk about identify the mean value of a data, then we must know that to get a mean, what type of data I required? Want a numeric data. Okay, so in case I have a numeric type of data with us, I can find a mean as a feature. But what if I have a text? Can I find a mean? I cannot find a mean for the text data. So this data really plays a crucial role. if we have a knowledge, we have the interpretation about this data, then only we can talk about the feature extraction phase of our machine learning. What type of features we can work on. Okay, so in a machine learning, we are able to work on 4 different type of data. The very first, numeric. Second, categorical. We have the images, we have the labels associated with us. We have the time series, videos, we have the stock price type of thing which keep on updating in a timely manner. And last one is the textual data like a natural language in a text form. So these are the 4 different type of data which is available in a machine learning community. And if you want to work on, we have a very good resources where we can get these data to work on. If we want to work on in a machine learning, we can get these 4 data using these 4 some digital repositories. Other than this, we have some other platforms like a Kaggle. We have some other platforms like a Grand Challenges websites where we can get the imaging type of data. So first, now we are able to get this data. We have the data. We have collected this data. Next phase is on doing a pre-processing, which is actually required. Why pre-processing is required? Because whatever the data we have collected till point of time, we cannot say that that data is completely in a transformed manner, or my model is able to read that data in a current form. Suppose you have acquired one image. Okay, we have acquired one image from the sensor, and that image is taken in a noisy environment. Okay, so what will happen? This noise can create some impurities in my signals. Once the signal is flowing, some noise is there, then signal will get distorted, and that distorted signal, once is transformed into the pixels, we can get some noisy data. So are that noisy data create some problem or not? We are actually unaware about it. Maybe or may not be, because we are not the right person who can tell that in a noisy environment, definitely you will get this distorted image. No. Okay, we cannot say this. So before process our original data to our machine learning model, we need one intermediate phase, which is called my pre-processing. That means I need to do some cleaning part on my data. I have to do some transformation on my data. I have to do some reduction part on my data. Okay. So in case if we have done these 3 transformations like cleaning, is there any missing value? Okay. Is there any missing value? Then we can handle that part. In case we have some noisy data, then we can apply some filtering, we apply some regression, linear regression, non-linear regressions, and we can get rid of those noisy data. We have the transformations like the normalizations. Can we do a data normalization? We have the histogram-based approach. We have a different approaches by which we can normalize our data. We can do the discretization, concept hierarchy generalization. Then we will move towards the reduction. The one most common reduction is our dimensions. We talked about original data. We have a 1024 cross 1024 size of image. And now we transform this into 256 cross 256. Okay. We have done this transformation, this reduction of the dimensions, so that my model can work effectively and in a less time consuming as comparative to 1024 cross 1024. So, but this reduction should not be up to that level which can distort the data. So we need to understand first that up to what extent we can reduce our dimensions. Okay. Otherwise, our data can be distorted. So this is the overall picture of your data engineering, data science, where once we talked about this raw data, processing, cleaning, analysis, and the algorithms with the later visualization. This part is actually coming under your data science. Okay. With the data science, if we will keep add on the neural networks over the models, where we have the algorithms, statistical algorithms, till that we are working on our data engineering. Beyond the algorithms, we add on neural networks, data productions, new data generation, intelligent agents, then we can say that we are actually moving towards the era of artificial intelligence or my deep learning. So AI or the deep learning is more related towards the use of neural networks family in my modeling type of thing. So I will tell you about more about this deep neural network and the neural networks families, what type of networks we have. So this, if you will talk about this machine learning, we will see intelligent agents are out of this box, because this is a part of AI based system, external agents. So once we are done with the cleaning process, next phase is your data partitions. Okay, so we have this data which is going to be partitioned into different levels, like your training data, validation data, test data. Okay, so what training data will do? Training data is going to help you to make your model learn as much as you can. Okay, while validation can help you to understand that your model is actually working in a correct manner or not, whether your model is under overfitting or underfitting or not. So you can check it out, this thing. While your test data is going to use to make the model to find the accuracy. But in general, if this is a partition based on your data set. But once we talked about the general terminology of machine learning, then we have two type of data only, training data and test data. Training data is what on which we can train our model, and we can check our model's performance before releasing to the market. That's our training part. While test data is totally unsupervised, we do not have the label associated. It is going to be used just to test that whether our model is giving the accuracy, not the accuracy, to test what type of label we can get using this learned model. Okay, think about the concept in a form. Suppose I have the medical images data set. Okay, I have all the data sets of cancers. Either it is of skin cancer, it is of brain cancer, it is of liver cancer. What type of cancer? I have the cancer data set. I have done my model train on the cancer, and now I have released my model to the market that you will pass an image. It will give you whether the patient is having a cancer or not, or a cancer is of which grade, 1, 2, 3, or 4. Done. Now this is a model. But how can I ensure that my model is perfect? That we can claim with the help of our validation data. Okay, we break this data in two forms while doing training before releasing to the market. 80% data, suppose I have split this in 80 and 20. 80% data I have used for the training part. I have trained the model. 20% I have kept for validation. In a validation, I have passed. If we will talk about the data, so this data is having, suppose, n columns, and these n are the features which are associated with one vector of object R1. Row 1 is a one vector of object having n features F1 to Fn. And the last column of the your data is the class label which is associated with it. So while training, we will pass this n plus class label, n plus 1 columns to our model, that this vector, these feature means this class label. And that is how we keep on learning our model. But while validation, what we will do? We will pass only n features to our model, and we ask the model to give me the C dash last column. You will give me what labels you can give me on these sample test validation 20% data. Once we get those labels, we can now compare C dash with my C. Okay, suppose there are 100 samples in a validation set. Out of these 100 samples, 80 samples are correctly identified by my model. Then my accuracy of my model is 80 by 100, which is 80%. So I can claim before releasing to my commercial market that my model is 80% accurate to predict whether a patient is having a cancer or not. Now test data is totally unsupervised, because it is that data on which we want to get the label. We do have no associated label of. In case we have the label, then why will check our data with the model? We know that this label of test sample. So what we will do? We will take this sample on which we have no idea about the label. We will pass this label to our model, and model will give me one class label. And now I can say that 80% chances this given input is having this cancer. Rest you can validate clinically. So this is the power of this distribution. This is the power of your machine learning division of this data set into the training phase, validation phase. So till this, we have the data. We have processed this data. After processing, we have feed this data, and now we are more interested towards the features. How you can represent the features of the data so that your model can become learnable. Okay. So what type of features? Check about this image. If you will talk about the image, then what type of features we can associate with this image? We have the edges. We can identify the edges. We can identify the color. We can identify the movements, color movements, color histograms. We can apply the shift, scale invariant features. We can apply the DWT, wavelet transformation. We have the shape-based features. We have the texture-based features. We have the GLCM, which is a co-occurrence matrix type of feature. We have the PCA. Now this PCA word is exactly this keyword PCA is, you will find the use of this PCA in more towards the dimensionality reduction. Okay, but many authors, many places, PCA can also be used as a feature representer. Why? Because once you transform your original values to a new dimensional space, and you can find that dimension space the principal components, then those components are the new values, which is actually not discovered earlier. So many authors have used those new values as a features for image representation, and this PCA is having a power of retransformation. You can retransform image back from the given PCA components. So because it is totally lossless type of thing, so many authors have used these new transform values for images to get the feature information. Beyond these images, in case if we have the audio signals, then what will happen? These audio signals will have a different type of feature. We cannot use these shape, age, color, DWT or the PCA on my audio signal. Audio signals can be used in, we have a different type of features. Mostly electronics department, they work on this type of aspects.
linear predictive codings. We have the MFCC, male frequency septal coefficients. We have the PLDA, probabilistic linear discriminant analysis. We have the raster filtering. So these type of features are able to help us to get the amplitudes, frequencies, coefficients, and those coefficients, those frequency components is going to help us to get our samples learned by any machine learning model. So how much time we have? 5 minutes. Okay. So feature selection. Once we are a big pool of these features, now can any one of us will say that whatever I have extracted, I have used these 8 features. Each feature have multiple sub features, like GLCM alone can give you 28 features. Not 28, exactly 56 features. We have the 4 orientations: 0 degree, 45 degree, 90 degree, 135 degree, and at one orientation we are able to fetch 14 different features. So we can get 56 features alone from GLCM. So what, in case I can give you a more detailed explanation on this feature extraction phase later on. So what if we have extracted thousands of features, hundreds of features, then can we say that all these features are important to us? Maybe or may not. We are not confident about it. Suppose if I will find the standard deviation of my data and the variance, can these 2 features will give me 2 different informations? Standard deviation and a variance. We have the relation. One is the square root of other. Done. So what is happening? We cannot say that we are, whatever we have extracted, we are getting all the relevant information. So our task, if we will feed all these features to our model, then model is bound to use all the features to get learned. And once it keep on iterating on these irrelevant features, then might be your model will fall under overfitting conditions. Okay, so what is needed? Feature selection. So we have the feature selection methods where we can use in a supervised manner. We have the wrapper classes, we have the filter, we have the embeddings. Wrapper, feed forward, backward selection, recursive feature elimination. We have the 3 different algorithms on which we can work on. We have the filter, like we have the chi-square test, F-score, mutual information. We have some different type of ratios. We can apply these filters and we can remove some irrelevant and redundant features which are not actually playing any role in our feature engineering. We have the embeddings like an autoencoder. One common example of embeddings is your decision tree, which has an inbuilt feature selection power. Okay, so like this, we have the algorithms, we have the methods on which we can work on with this reductions of the irrelevant and your redundant features. For the unsupervised, where we have no information whether the feature is actually helpful or not, we have a different aspects like drop incomplete features. We have the drop features with high multi-collinearity. Okay, 2 features which are highly correlate, highly collinearity. That means if we are talked about the cosine similarity aspects, 2 features which is having a collinear to each other, then we can say that we can drop these features because all the features are giving us the same information. We have the drop features with almost 0 variance. Okay, so what is we are interested? We are more interested towards the Gaussian distribution. We will make a Gaussian distribution with the 0 mean. Having a 0 mean, then those features having a 0 mean, they are not going to play any significant role in our segmentation task. So what we will do, we will drop it and we will take care of where we will get the unit mean. Okay. So that's it about the up till feature selection phase. After the feature selection, we will start the modeling part, and where the roles of classification and segmentation will come. So I think that classification is covered in tomorrow's lecture as per the curriculum which you have passed. So we will talk about the existing classifiers. Moreover, I will give you some brief introductions about each of the phases on which we can work on independently, but with some new aspects of introducing some new algorithm rather than using the existing one, so that we can generate some new contributions in a machine learning aspect. Thank you, everyone. So in case any questions, please, I'm ready to take.